Hello everyone. Today we will learn section 4.5, the chain rule. Okay, so we have a learning objective here. In Calculus 1, how do we do chain rule? And also we are using when the partial derivative, right? So if we have a composite function, we do derivative outer function first, then inner derivative, right? How do we make a chain rule in calculus 3? Because we have more than one variable, right? So calculus 1, we have only deal with x or t or any variable, only one variable, right? For calculus 3, we have more than one variable, right? Okay. It's a similar concept, means that with the derivative outer first was inside, right? Derivative was inside. So then here we have more variables, and then we have another variables involved with them. Okay, so let's take a look. We have independent variables. We say that x and y, and then we have dependent variable, which is t. Then we apply the chain rule there. Okay, let's take a look. If we want to make dz over dt, means that with the derivative z respect to t, right? Okay, then we don't derivative only one variable. We learned that, right? So we always do partial derivative. So in here, partial derivative with respect to x, then we're looking at the x equation, we do derivative with respect to d. All right. Okay. Then we add them with the partial derivative with respect to y, looking at the z equation or the function, right? And then with the derivative y respect to t. All right. Okay. So we talked xy is we have intermediate variable, which means independent variables. And then I introduced you earlier, the t is dependent variable. Okay. All right, let's do example. So here is the example. Calculate dz over dt. So we have equation and function. And then also we have the equation of x respect to t, right? Okay, let's do this one. So we have dz over dt. Then the formula is this. Come on. Oh my gosh. Okay. let me just write down. So we have dz over dt equal to partial derivative respect to x. And then we're looking at the x equation and derivative with respect to t, right? Plus with the partial derivative with respect to y, and we're looking at the x, y equation, and then with respect to t, right? Okay, so this is the formula. Okay, let's do this one. Let's try the z over, okay, maybe we can do one step. So equal to, looking at this equation, we do partial derivative with respect to x. That is 8x. Okay, we're looking at this one. The x over dt means we're looking at the x equation, and with the partial, not partial, oh my gosh. With the derivative with respect to t, what do you get? Cosine t, right? Very good. So we have a cosine t plus, okay, we do partial derivative with respect to y. So we have a 6y, right? And then we're looking at the y equation, and then we do derivative with respect to t, which is negative sine t, right? That's it. Okay, so since we have a negative here, let's just arrange a little bit. 8. Okay. And also we need to make in terms of t. Yeah, everything. Then what is the x? X will be sine t. Yeah, so there will be sine t. Sine t. And we have a cosine t there. Plus or negative 6. What's the y? Y is the cosine t. So y y is cosine t. So we have cosine t. And we have a sine t, right? Sine t. All right. Then it's the same. 8 sine t cosine t minus 6 sine t cosine t, right? Then what do you get? It's 2 sine t cosine t, right? 2 sine t cosine t. All right. Then this is one of a trig identity, which is the same as sine 2t. Do you remember this? Okay, very good. All right, so we can use another method like a channel. What's inside, right? So outer first, then inner, right? That kind of a method, we can use that. Okay, let me show you that. Another method. All right, so we have equation, this, copy. Okay, then we can express z equal to, we have z equal to f of x, right? What was the x? We can use x equal to sine t, right? What was the y? Y equal to cosine t, right? Okay, let's express that way. So we have z equal to f of x, y equal to, then f of, we can express x equal to sine t and cosine t, right? Okay, now then equal to, we have a 4x squared. You may write down here. So we have 4x squared, 3y squared. Then we can express this one will be 4x squared, which is sine t squared plus 3y squared, 3 cosine t squared. Okay, now let's say derivative dz over dt. So dz over dt, we can just using regular, the normal derivative, right? So looking at this one, we're not applying that formula earlier, right? So we have this, and then we do derivative with respect to t, right? Okay, then what do you get? So this will be 8 sine t, and what's the derivative inside, right? Like a calculus 1, right? Composite function, derivative of composite function. So a sine t, and then derivative with respect to t of sine t plus with the derivative, the second term, then we get drop the 2, so 6 cosine t, and then we do whatever inside derivative, right? General. So we have 6 cosine t, derivative was inside. That is a chain rule from the calculus one, right? So we're not really using that formula, right? Okay, then what do you get? We have a sine t, derivative of a sine, which is cosine t, and plus 6 cosine t. What's the derivative cosine t? It's a negative sine t, right? So we have a negative sine t. Okay, we have experience earlier, right? So let's skip the one step. So a sine t, cosine t, negative 6 cosine t, sine t, which is 2 sine t cosine t, right? Which is same as sine 2t. Yeah. Okay. So which one is better for you? This one is better, or this one is better, right? Okay, let's try other formula. I mean, other example. Okay, so here is second problem. So we have a z equal to that function, x equal to e to the 2 to the t power, and y equal to e to the negative t is negative. Okay, so we want to know derivative with respect to x, and then we do derivative with respect to y, and then we do derivative respect to t, we do derivative with respect to t. Yeah, so let's do that step by step, step by step. And then we arrange those terms, and then we want to rewrite everything in terms of t, right? That's the dz over dt, right? Okay, let's do it. So let's do derivative, partial derivative with respect to x, yeah? Okay, so we had experience before, so square root is 1/2 power, right? So we drop the power and then reduce by 1 will be 1 over that. Sorry, 1 over 2 of square root of x squared minus y squared, right? Okay, so let's do it. 1 over 2 and square root of x squared minus y squared. And then we need a derivative inside. We are using, this is a calculus 1 chain rule, right? So this one is also partial derivative, right? Because we have to do that. So partial derivative with respect to x. And what's inside? X squared minus y squared, right? Okay, then numerator we get 2x over 2 times the square root of x squared minus y squared. Simplify, we have x over square root of x squared minus y squared, right? Okay, that is partial derivative with respect to x. Let's make a partial derivative with respect to y. Same, isn't it? And then we change a little bit, right? And then partial derivative with respect to y, right? Okay, so that will be negative 2y then, negative 2y over 2 square root of x squared plus, no, minus y squared. Simplify. Ooh. Then negative y over square root of x squared minus y squared, right? Okay, now we're looking at the x equation, dx over dt, derivative with respect to t, e to the 2t, and chain rule times 2. You guys okay with this, right? So 2e to the 2t, yeah. All right, now we're looking at y, derivative with respect to t. Oh, e to the negative t and times chain rule negative 1, right? So what's the derivative of negative t? It's negative 1. So we had the experience previous, right, section. So negative e to the negative t. Yeah. Okay. So we have the formula. Copied. Yeah. And then we have to write out in terms of t everything. Okay. All right. So there will be dz over dx. I mean the partial derivative with respect to x, right? So we have x over square root of x squared minus y squared and dx over dt, which is that 2e to the 2t plus partial derivative with respect to y, so negative y over square root of x squared minus y squared, and dy over dt, it's negative e to the negative t. Oh, you cannot see, sorry. Okay, let's do that everything. We need to substitute where x, where y, right? So x equal to, let's see, we have x equal to that, y equal to that, right? So use. All right. So we will have e to the 2t. And let's simplify. So e to the 2t over 2e to the 2t square root x squared e to the 2t minus n squared, right? Squared minus y, which is e to the negative t squared. And minus is a positive, right? So it's a positive, y equal to e to the negative t, and e to the negative t over square root x squared, which is, I can just copy from the here, right? Just copy. Okay. Let's make a common denominator because denominator is the same, right? Uh, 4 over square root. So we make a square inside. So e to the 40 minus e to the negative 2t then, right? So e to the 4t minus e to the negative 2t. And then we have 2 times. Okay, so we get 2 there. And then we have the same base. We add their power. So 2t plus 2t, which is 4t, right? So we have a 2e to the 4t. Oh, you did not see. Okay. All right. Then also here, same base, then we add their power. So e to the negative 2t then. Yes? So plus e to the negative 2t. Yeah. All right. So let's just leave like this. Okay, now what if we have more than one independent variables? Let's take a look here. General for two independent variables. So x equal to g of u v. So we had earlier only x equal to only one independent variable t involved, right? So in this case we have only u and v. All right, so let's take a look. So we want the derivative, partial derivative with respect to u, then partial derivative with respect to x. Since we have x equation has two variables, right? So we do also partial derivative with respect to u. And then we're looking at the z equation, partial derivative with respect to y. We're looking at the y equation, partial derivative with respect to u. All right? So everything in terms of u in that case. Okay, let's take a look at this one. Partial derivative with respect to v. Then we're looking at the z, partial derivative with respect to x. We're looking at the x, partial derivative with respect to v. We're looking at the z, partial derivative with respect to y. We're looking at the y, partial derivative with respect to v. All right, so let's do example. So we have an example here. And then we want to find partial derivative with respect to u and partial derivative with respect to v, right? Okay, so let's bring this one. Copy. Okay, so take a look. We're looking at the z partial derivative with respect to x, right? So we have 6x and y is constant, so negative 2y and 0. Make sense? So negative 6y, negative 2y. Yeah. So negative 6y. I'm sorry. Negative 6x minus 2y. No, where's the negative 6x come from? Positive. Sorry about that. All right. So we finished that. How about this one? Looking at the x, partial derivative with respect to u, then there will be only 3. Can you see? Yeah, move up a little bit. Ooh. Then we get 3. Yeah, plus looking at the z, partial derivative with respect to y. So 0 this first term, looking at the second term. So negative 2x then, right? Negative 2x plus 2y. Can you see? Okay, very good. So negative 2x plus 2y. And then looking at the y, partial derivative with respect to u. So positive 4. Okay, let's arrange. And then we want to know about in terms of, we have to write down in terms of UV, right? Yeah, okay. So we do distribute. So we have 18x minus 6y minus and 8x plus 8y. Yeah, simplify. 10x plus 2y. Okay. So we want to rewrite in terms of UV, right? Because X of UV, Y of UV, right? Okay. So X, 10X will be 3. So X is 3. U plus 2V plus 2. Y is 4U minus V, right? So 4U minus V. Combining, distribute. So we have 30U plus 20V plus 8U minus 2V. Okay, so there will be 38U plus 18V. Yeah, so this is the one. Okay, let's do other formula. So we have this one. Copy. This one. We have to have everything, huh? Okay, so I want to bring this one more time so that we can calculate, right? We can find the partial derivative. All right, so let's do it. I think we had this one. So we had a partial derivative with respect to x earlier, right? So we had 6x minus 2y. And we need to think partial derivative with respect to v. So we get just a 2, right? And we had this one earlier, partial derivative with respect to y. So negative 2x plus 2y, right? And we need to find partial derivative with respect to v. So negative 1 then, right? Okay, distribute. We have 12x minus 4y. Minus minus is positive 2x, negative 2y, right? So there will be 14x, negative 6y, right? Okay, so x equal to 3u plus 2v, right? So 14, 3u plus 2v minus 6y, y equal to 4u minus v. Oh, it's black? Okay, hold on a second. 4u minus v. Okay. Distribute. So we have 14 times 3, 42u plus 14 times 2v, 28v minus distribute 24u plus 6v, right? Combining like term 42 minus 24u 18 18u plus 34v. Yeah. Okay. Good job. Okay, now we have theta 4.10. What if we have more variables, right? Okay, then we can extend everything. All right, so let me show you with an example how we extend the partial derivative. All right, okay, so here's the example. Calculate partial derivative with respect to u and v. Okay, let's find out. So partial, let me using different colors. So partial derivative, looking at the w, partial derivative with respect to u. Okay, we're looking at the w, right? But then we have three variables, x, y, z, right? Then we have the partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. And then we're looking at the x, partial derivative with respect to u. Looking at the y, partial derivative with respect to u and u, right? For the z, right? That's how we do. And this one, partial derivative with respect to v, same concept with u. This function is the same partial derivative x, y, z. But then looking at the x with the partial derivative with respect to v. Yeah? Okay, let's do it. So let me write down. So partial derivative with respect to x, partial derivative with respect to y, partial derivative with respect to z. And looking at the x, partial derivative with respect to u, right? So and u, partial derivative with respect to not w, y, u, and z, partial derivative with respect u, right? So All right. Also, we can see that everything is dx, dy, dz will remain partial derivative with respect to u, right? Like this. Okay, let's do it. Looking at the partial derivative with respect to x, so 6x minus, oh, sounds familiar, right? So looks like an earlier question. Minus 2y, yeah, 6x minus 2y. Okay, we're looking at the x, partial derivative with respect to u. Okay, so u, e to the u, sine v is the constant, so we keep that, right? So constant, like 2 or 100, we keep that. 100 e to the u, right? So e to the u sine v plus partial derivative with respect to y with the w equation, so negative 2x, that's it. And partial derivative with respect to u for the y equation. So cosine v is constant, so we keep that. So cosine v e to the u, right? Okay, the last one, partial derivative with respect to z, so 8z, right? And partial derivative with respect to u, oh, e to the u, right? Nice. Okay, let's arrange. Uh, distribute first. So we get first one 6x e to the u sine v, right? Okay. Then minus, let's do one step. The x, can we substitute x, right? So let's substitute one step because we had experience, right? So x will be, let's see, x is e to the u sine v, e to the u sine v. Okay, minus second term, so we do distribute, and second term, negative 2y e to the u sine v, so negative 2y, oh, y, so y is e to the u cosine v, and we have e to the u sine v. Okay, so that's the first term. Second term, negative, negative 2x. So let me write down in the bottom. So negative 2x. So negative 2. X is e to the u sine v and cosine v, right? And the last term plus 8, z, z. So z is e to the u, right? E to the u. And we have another e to the u, right? Another e to the u. Okay, so the first term, we have 6 e to the 2u sine squared, right? So 6 e to the 2u sine squared v minus 2 second term e to the 2u e to the 2u cosine b sine b e to the 2u cosine b sine b. I'm thinking what we can combining like term. Yeah, or when I'm looking at this one, I think I made a mistake here. So negative 2x, x is that, and then missing this one, right? So missing this one. So let me write. So this should be, oh, sorry. This should be there. Yeah, that's why. Okay, now, all right then, let's take a look this one. So that would be, let me write down this way, negative 2 e to the 2u cosine b sine b, right? It's the same thing, right? Okay, now we can simplify later, combine the right term. Okay, and then plus, let me write down a to u then. A to e to the 2u, right? Okay, then that will be 6 e to the 2u sine square v minus 4 e to the 2u cosine v sine v plus e to, oh no, e to the 2u. 2u. Yeah, is okay? All right, so let's do partial derivative with respect to v. Okay, so let me write down partial derivative with respect to v. Okay, so we need a partial derivative with respect to x, y, z, and then looking at the x equation, partial derivative with respect to v, y equation, partial derivative with respect to v, z equation, partial derivative with respect to v, right? So let me write down x, y, z, v, 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 right? Okay, then we need the equation. So let's take a look. Almost done. We have implicit equation. Copy. So we have. Okay, let's do it. So partial derivative with respect to v, then looking at the partial derivative with respect to x, which is 6x minus 2y. Yeah. So 6x minus 2y. Okay. Partial derivative with respect to v. V then u is constant, so e to the u cosine v. Yeah. So e to the u cosine v. All right, now partial partial derivative with respect to what? Y, right? So partial derivative with respect to y. So negative 2x. All right, so plus negative 2x. All right, now partial derivative with respect v is constant. Oh, v is not constant. U is constant, right? So U is constant, we keep that. So e to the U, derivative of cosine V, which is negative sine V. So negative e to the U sine V. Yeah. So negative e to the U sine V. All right. Last one. Partial derivative with respect to Z, 8Z. And partial derivative with respect to v. Oh, then this is 0, right? Yeah, lucky. We don't have that. So we have to make it 0. Yeah. Then last term is 0. Oh, nice. Okay. So we substitute x and y. And let's arrange, right? So x, y, x, and z is useless there. Okay, so we have 6x e to the u sine v minus, distribute to 2. We did earlier like that, right? So e to the u cosine v minus 2y and 2y, y is e to the u cosine v and e to the u cosine v. Now, second term, minus minus is positive. So we have 2x. X is 2u sine v and e to the u sine v. The last term is 0, right? Okay. Same concept as earlier. So we get, let's arrange it first. So 6 to e to the 2u sine v cosine v minus 2e to the 2u cosine square v plus 2e to the 2u sine square v. Nothing to combining, right? Okay, done. Okay, now we have an implicit differentiation. So once again, calculus 1, we have y equal to something, just a regular equation. We say that explicit equation, right? Then those equations we can find easily about the slope, right? What about we have a crazy equation? How do we find the slope, right? Derivative. So those kind of equation we say the implicit equation, right? So how do we make equation nicely and then we find the slope by that, right? Okay, we don't have to make nicely for the implicit equation. We can just find the slope, right? That's how we using the implicit differentiation method, right? Okay, so let me just show you. So we have a crazy equation, like implicit equation. We want to find the slope. So dy over dx is the slope, right? Slope. Then we do derivative with respect to x, and then we do derivative with respect to y. So when we derivative y, we always say dy over dx. Chain rule, right? So we have that. So derivative of x squared, which is 2x, derivative y, which is 6y, and make a chain rule dy over dx plus 4y, derivative of 4y, which is 4 dy over dx. And then we need to solve for dy over dx. Then factor out dy over dx. Then we have 6y plus 4 equal to 2x. We put the other side. So negative 2x. Solve for dy over dx. Then we get that. So we want to know about the slope when x equal to 1, y equal to 1. Then we have negative 1 over 5, which is the slope, which is dy over dx. Yeah? Okay. Same concept in calculus 3, but we have a different formula using it because we have more than, actually in that case, x and y, right? With a partial derivative, right? That's the main idea in calculus 3, right? So we have implicit differentiation. So let's take a look. So we have a dy over dx. How do they find dy over dx? Then we have partial derivative with respect to x over y, right? Okay, so we have a three different formula. So if we have just a 3 dimension involved with 2 variables, then we are using this one. What if we have a 4 dimension? Yeah, involved with, we have 3 variables, then we are using this formula. Okay. All right. So let's do this one. This is the last question for this section. Okay, calculate the dy over dx. So we have the function. And then what is the equation of a tangent line to the graph of a curve at 2, when point is 2 and 1? Okay, so let's do it quickly. Dy over dx. So we are using this formula. And denominator cannot be equal to 0, right? Come on, let's do it quickly. Okay. Then negative sign, we can give it to numerator or denominator, right? So let's do it. Partial derivative with respect to x, what do you get? So 6x minus 2y plus 4. That's it, right? And then let's give it to negative sign on the top over, and then partial derivative with respect to y. So we're looking at this, negative 2x plus 2y, negative 6. Yeah. Negative 2x plus 2y minus 6. Okay, let's do one step. When the point 2 and 1, so we do distribute the sign, so negative 6, 2 plus 2y, 1 plus 4 over negative 2x, 2 plus 2y, y is 1 minus 6. Can you please calculate? Oh, so made a mistake, it's negative. So distribute the sign, right? So what do you get? 704? Yeah. So that means this is which is dy over dx. This is a slope, right? Okay, we want to know about equation of a tangent line. This one we can use the same as the algebra course, right? So equation of a tangent line. So y minus y sub 1 equal to slope x minus x sub 1. So we have slope equal to 704 and the point 2 and 1, right? Okay, so we have y minus 1 equal to slope x minus 2. I think this last one. Yes, last one. Okay, so y equal to 704x minus 14 over 2, sorry, 4 minus 1 plus 1, sorry. Yeah. Common denominator, so we get 7. Y equal to 7 over 4x. And simplify, negative 5 over 2 is okay. All right. So this equation gives us like this. And this is equation of a tangent line, which is y equal to 7 over 4x minus 5 over 2. All right? Any question? Thank you for watching. I will see you in the next video. Bye.